Today we're going to do Unit 1, Section 7, solving absolute value inequalities. And be excited, this is the last section for Unit 1. Amazing. Alright, so absolute value inequalities. So the only difference is, instead of equals, we have greater than, less than, greater than or equal to, less than or equal to, one of those, right? So that's the only difference. We're going to solve them the same. The change comes when we graph. So solving, totally the same. Graphing is what's different. That's it. So, just like before, I want my absolute value to be by itself, which means this 3 has got to go. Oh no. Don't do that. Okay. So I move that over. And from here, now that it's by itself, I can split it up and do 2x plus 2 is greater than 8. And, okay, yeah, there is a difference. I just thought of it as I'm doing this now. Whenever we do the second one, 2x plus 2, and we make it negative, just like with inequalities, when you make something negative, you're going to change the sign. So that's important to know. My signs are going to be different, and my numbers are going to be positive and negative. Okay. So make sure you do that. The biggest one is the signs, and the signs and the inequality sign. So both of them have to change. Okay. So we're still going to solve the same way. We're still going to move the 2 over here. 2x greater than 6. Divided by 2. So I have x greater than 3. Now on the other side, I'm going to move the 2 again, same thing. 2x is less than negative 10. So x less than negative 5. So there is a technical way to write these. So I'll go ahead and write that on the top as soon as this moves again. There we go. So my actual answer, the way I would want to write this, I mean, you can leave it separate. That's not really wrong necessarily or bad, but I do want to teach you the right way. So I am going to do x, I'm going to do the smaller one, or less than. So x is less than negative 5, or x is greater than 3. So that would be how I'd want to write this, is or. And now when I graph it, again, this will be just a little bit different because now we do have to draw an arrow or shade something, right? So I'm going to go ahead and do negative 5 down here. So 4, 3, 2, 1, 0, 1, 2, 3, right here. So now it's important to know that, look at my signs. X is less than negative 5, so from negative 5 I can go left. That would be my arrow. And then the other one, x is greater than 3, so from 3 I'm going to go right, that's greater than. Draw my arrow and I'm good. The other way you can tell that these go apart is the word in the middle is or. Think of oars on a boat, right? The oars go apart from each other or outside the boat, and there's nothing in the middle. That's where you're sitting. So it's kind of the same thing as that. And another neat little trick too, if this helps, is this symbol right here, greater than. Anytime you see greater than, it's automatically going to be or. Okay? So that's something you can write in the notes if you want to. Greater than, or greater than, equal to, even if it's underlined or not. Greater than is or, always. Okay? So that means they always go apart on the graph. So that's number 1. So let's do number 2. Right away I can tell this is less than. Okay? So less than is going to be and, not or. So less than or less than or equal to is and. Greater than or equal to is or. Okay, so we're still going to solve it the same way though. I want my absolute value by itself. So I need to divide by 2 on both sides. So absolute value x minus 1 less than or equal to 5. And now I can split it up. So remember, the first time you just write it normal without the absolute value. The second time, I start with the same x minus 1, but I flip my inequality and add a negative. Okay? And now I can solve for x on each one. So add 1 on both sides. X is less than or equal to 6. And on the right, add 1 to both sides. So I have x is greater than or equal to negative 4. And of course, I'm going to show you the right way to do this. So again, I'm going to start with the lowest number, which is negative 4. So I have negative 4 less than or equal to x less than or equal to 6. And that's it. So notice the big difference between this one, that's and the first one, that's or. So or, I have to write the word or. That's the only way I can do it. And you can just put x in the middle where it is, or if you really wanted to, just another way, I don't ever use this way, you could write both of mine separately. So I could do, I could do x is greater than or equal to negative 4 and x is less than or equal to 6. Now to me, I don't like it that way. I'd rather just do it the way I did it the first time because it's less writing, it looks nicer that way, but either way is correct. So whatever's up to you, either way is right. I'm not going to take out for one or the other just because you prefer to have and there or you don't. Because a right answer is a right answer, even if it's slightly different looking. Alright, the other thing we got to do is graph. So again, I'm going to start with the lowest number, so negative 4 down here. So 3, 2, 1, 0, 1, 2, 3, 4, 5. Oh, I got lucky. 6. Now, because I have an and, remember ors go apart, but notice my x is in the middle of these two numbers, so just like my x is in the middle, so is my line or my shading is going to be in the middle, because I want to connect them. So ors go apart, ands go together, always. Okay? Ors go apart like a boat, ors on a boat, and and is always, it's just opposite, just they go together. So that's the basic absolute value inequalities on a graph. So let's go down to 3 and 4. Notice I add the words if possible. If you ever see that, I would always be careful, because not necessarily does that mean you'll have no solution or extraneous solutions, but it's possible, right? So I'm going to go ahead and look at this. Look at, I have my absolute value already by itself. But if absolute values have to be positive, could I ever be less than a negative number? No, that is not possible. So I don't have to do anything on here at all. No solution. And then that's it, and done. So again, if you ever equal a negative or you're less than 0, less than a negative, not possible. So you have no solution, no work. Sweet. Let's get more of those, right? Alright, last one over here is 4. Notice I have my absolute value already there by itself. And I'm greater than a negative, which is fine because you can be 0 or higher, so that's okay. Not a problem. But since our absolute value is by itself already, I'm going to go ahead and split it up. 2x plus 4 greater than or equal to negative 4. And 2x plus 4 is less than or equal to positive 4. Remember, you got to change both the inequality and the sign. Now I can solve. Minus 4, 2x greater than or equal to, was that negative 8? Divided by 2, that's negative 4. Okay, so x is greater than or equal to negative 4, that's one answer. And the next one, minus 4, minus 4. That would be 0. Oh, sweet. Divide by 2, so x is less than or equal to 0. Alright, so again, we can write this the other way. I could do negative 4 less than or equal to x less than or equal to 0. Sweet. Oh, except I forgot one thing. Because this is a greater than, remember greater than or equal to are ORs. So I have to write this separate. So I'm going to have, here, let me put it in order. So I have x is greater than or equal to negative 4, or x is less than or equal to 0. So remember, ORs have to go separate, and they go apart from each other, like opposite directions. They have to. So this one, again, this is a special one. That's why it's down here. So this might look funny. So I have a negative 4, and then 3, 2, 1, 0, right? Now when I do this, I follow my sign. So x is greater than negative 4. So I go this way. Notice I pass a 0. But because this is not an AND, because it's an OR, I keep going. That's just how you have to do it. Only ANDs are connected. ORs are never connected. So I can't stop at 0. This is not an AND. It's an OR. So OR has to keep going past 0. And again, it looks funny, but that's why this is special. Now look at the other one. X is less than or equal to 0. So I start at 0, and less than goes down, or to the left. So notice they overlap each other because they do that with ORs. ORs never connect. They go opposite directions. We did that. And because they overlap, notice there's no gap in this at all. There's nowhere on this line that the answer, or I couldn't use a number, right? So now I'm going to change my answer after graphing, and I mean, for the most part, the graph is going to help you see this. So if my graph overlaps like this and it creates this whole line that's filled up, I would actually have all real numbers. Or you can write all real numbers. However you want to write it is up to you. So I can do the symbol, or I can just write all real numbers. Either way, this is a special solution, which is why it's down here by itself. And that's it for absolute value inequalities. So you have your normal ones, your AND and OR, and your special ones, your no solution, and your all real numbers.